Hello, hello, hello. Good afternoon, everybody. Welcome to my talk. Today I'm going to be talking about threat modeling and AI. My name is Shweta Devnayakam. I am currently a lead product security engineer with Salesforce. Prior to that, I was working in a software security consultancy for 10 years. So I have about 15 years cybersecurity experience. Again, this talk is not sponsored by my company. These are just my views. Okay, so starting off, I know we've had a couple of workshops, talks, touching upon threat modeling, what that is, but I just wanted to level set. Let's start from the basics. So what is threat modeling? Why are we doing it? So the biggest advantage of threat modeling, as we are talking about it right here in the design phase, and here we're talking about software security applications, is to be able to identify any threats or attacks as left as possible in the software development lifecycle. So right from the design phase, we want to be able to look at our systems and say, something's wrong here. Something that's being built could result in things going really bad. So as part of threat modeling, what we're looking at is what are we building, what can go wrong, and how can we fix it? There are some common frameworks that are available that a lot of software security professionals use for this. Stride is one of them, originally from Microsoft way back in the 90s. There are some additional frameworks that are being used. There are new ones coming up. OWASP has recently released something for Gen AI applications as well. So there are many different frameworks that folks use based on your applications, your program, and things like that. When we talk about AI-driven threat modeling, why do we want to use AI here? So one of the main components of AI that has made it so very popular in the last couple of years, the natural language understanding, natural language processing ability, is one of the things that helps us greatly here as well. So when we talk about threat modeling, we're talking about looking at architecture diagrams, maybe looking at PIDs, data flow diagrams, confluence pages, a lot of text, a lot of diagrams. LLMs are very good at looking at these, parsing these, processing these, and finding out threats from these. So this is a very good kind of use case to use LLMs for security. What they can also generate is automated attack scenarios. So just like LLMs are good at generating code, they are also good at generating attack scenarios. They're good at generating threats. They're good at generating possible issues with the system. So that's another place where they really help. And we'll also talk about some of the pitfalls here. We can use LLMs, we can do all of these things, but what are the gotchas there? What do we need to be aware of that will cause issues in the future? Talking a little bit basics, we mentioned Stride before. This is what Stride stands for. It's an acronym, STRIDE, spoofing, tampering, repudiation, info disclosure, denial of service, elevation of privilege. These are various different categories of threats that your system could fall under, that your LLM or whatever you're using to run the threat model can categorize your issues into. So this is a framework that we can provide, that we can use ourselves. It's used while we do manual threat modeling. It's also something that we can use while doing AI-driven threat modeling. This is a sample AI-driven threat modeling workflow. Again, this models very closely with how human-driven threat modeling works. Threat modeling by humans is something that's been going on from a really long time. Back in the day, it would be a couple of security architects, security consultants looking at a system, spending weeks, looking through all of the different components, how they talk to each other, devising attack scenarios, enumerating the threats, and creating like a 15-page report out of it. We are going to use the same philosophy, but use an LLM to do this for us. So the very first part of this is, right, ingest the data that's available. So this could be architectural documents, this could be some sort of code, this could be pages from, like I mentioned, Confluence, Slack messages. Wherever your documentation exists, that needs to be ingested by the application that's doing the threat modeling for you. Second step here is decomposing it. So modern applications are extremely complicated, right? They are not anymore a monolith, monorepo with, or at least they shouldn't be running, thousands or more millions line of codes. They are microservices. They are talking to each other. They're deployed on AWS. They are, deployed on Kubernetes. They have libraries, 3PPs. They have internally developed libraries which they depend on. So it's a very complicated landscape, and the most important part of it is for the LLM to understand what these different components are, how they talk to each other, what are the trust boundaries between them. And then the next part is to, reason, do the attack scenarios, do the attack paths, list out the attack vectors, use any additional data that's supplied via RAG or other forms of indexing, use all of that additional information and create a JSON or Markdown or whatever format of output. And the last step, of course, is human triage. Again, while we talk later, we're going to talk a little bit more about, what are the limitations of these systems? Why do we need a possible human triage? How can we scale this element of it? So this is an example of StrideGPT. It's an open source application that does GPT automation. I picked this because it's something that you could run locally in your, you can host it on your system. You can run it on your browser. You can upload documents to it and have it analyze it, just as a test. One thing to note is that it uses an LLM in the backend. This could be, you could provide it OpenAI API keys or Anthropic, Google, whatever. So if you are using something like this, you are giving it some documentations, you're using OpenAI, understand that your data is going to go to OpenAI. So privacy and security, again, is very important. We need to understand where data is going when we use these LLMs. It also has an option, yes?
Okay, can you point it at a custom in-house
Yes.
LLM?
Yes, you can also use local LLMs to do this. Ollama, LLM Studio, whatever local LLM you have. Again, that prevents some of the other issues, security issues that could pop up if you're using external LLMs. So it does the same workflow that we talked about. You upload your documents to it. You can add some system descriptions about what your system is. You can upload architecture diagrams to it. It uses the LLMs to understand the data flow, understand the design flow. You can provide it if you want. If you have some source code, you could provide that to it. It also has many inbuilt prompts already. So that's something that you can use right off the bat. The prompts help it do the analysis, do the report generation. You can refine the prompts as you wish. If you're running it locally, you can do some custom prompts if you like as well. And again, the last step here, once it runs the prompt, it sends it to the LLM. It then renders the data in the format that you want. It could provide the threat model, the attack trees, mitigations. It also has a really nice little output where it tells you what additional data you could provide it to make the threat model better, which is a very good. It helps you learn what additional things it needs. These are some general. Oops. I don't know what happened there, but so going forward, I'm just going to keep talking with this. So while using prompts, what is very important is to understand how to maximize your, the feedback that you get from the prompts, right? Prompting strategies are very, very important. And then there are many best practices that are available from Claude. Claude has published a list of best practices. Other tools have their own best practices as well. That really helps you to understand how you can get the best responses from the LLM. So some of them is be direct. You know, when you're asking the LLM to do something, make sure that that you provide it a direct thing. Skip the fluff. You can ask it to think clearly, think through with your chain of thought. So you can tell them, give me step-by-step reasoning, and then that helps Claude actually do a step-by-step reasoning and think through it much deeper. You can give Claude a role. So you would say, okay, Claude, you're a software security consultant, you're a software security architect, and then that helps it set the tone for the response. It says, okay, you are a security consultant, the response I want needs to be a technical response. You can give it examples. So, you know, when you have output style or format, just give it a few examples. This is the sort of response that is good. This is the sort of response that is bad. Give me the correct response. And then avoid ambiguity, right? As with any AI, just be as clear as possible. Avoid ambiguous statements. I'm going to give this another go, but we can keep going. Avoid ambiguity. Just be as clear as possible to Claude when you give it the instructions. Okay, awesome. Right on time. So this is an example of the sample prompt from StrideGPT. This basically tells the LLM what it's looking for in the threat model. So you want to prep and identify. And this is where the stride categories, you're supplying it the stride categories, you're giving it output format on how you'd like the output to look like, and you also give it instructions on analysis. So, you know, give it specific scenarios. If there's something specific that you're worried about for your application, external facing, internal facing, you can supply all that information. And this is another sample prompt that is used by StrideGPT for analyzing data flow diagrams. So you can give it an option. You can tell it, again, this is where you supply it the role, and then it uses the previous information that it gleans from reading the data, from reading the stride categories, and then you can tell it to analyze the components, analyze the relationships, identify protocols, and provide you the threat model. So all this is great, right? Like, have we solved threat modeling? Just push it to an LLM, you get a response, you get a threat model, you're done. Like, my job is done. I no longer have a job. Luckily, it doesn't work that way still. One of the main things that you will see when you start doing this, and whichever model you use, whichever type of framework you use, one thing that's missing and that really, really impacts the value that you get is context. So when you talk about very, very large enterprises, and when you talk about very, very large connected applications, it's not as straightforward as, okay, I have one clean architecture diagram that encompasses my whole system, that shows all the interactions with every different type of user, that shows the database that I have, that shows everything that I have. No, we have like hundreds of microservices talking to each other. We have connected apps talking to each other. We have external customers. We have multiple types of authentications. We have third-party applications. We have so much context. And unless that is supplied to your threat model engine, the results that you get back are not going to be up to par. Especially when you talk about, okay, as a security architect or as an engineer, you're going to run this tool and get 10 findings back, and maybe one of them is relevant, right? That doesn't work when you have to scale this. So we have everything happening today. So yeah, continuing on. Again. So yeah, context is key, context is king. That's where all the secret sauce is in here. I want my system to be able to understand what is specific, what is idiosyncratic about my company, what weird things are we doing in there. My threat modeling engine needs to be able to take those into account, or else it's not giving me the value that I need. Moving on to, general limitations of LLMs, hallucinations. They are getting better. We've had a couple of the LLM models keep improving on these, keep improving on reasoning. They still exist. Non-determinism is a big thing when we talk about, using these in continuously. If I run this once, I get 3 findings. If I run it 2 times, I get 5 findings. Like, what do I tell my developer, right? Like, why am I giving you random findings every other cycle? So understanding that, and that is how LLMs function. So it's an inbuilt paradigm of LLMs. So you have to deal with that. That is another big thing. And again, context rot, window limits. When we talk about very, very large applications, a lot of context, a lot of data, these can result in some of that context, windows getting overflown and context getting lost. So when we talked about earlier about having human in the loop, again, that's a scalability problem. When we have developers developing at AI scale, as security engineers, we can't always be the human in the loop. We have to use some additional strategies to increase the fidelity of these findings. LLM as a judge is one of those strategies which you can use. So you have, you run through the LLM, do the threat model, then you have an LLM as a judge to judge the output of that threat model. So basically, you can you can give it specific instructions on what you're looking for from the output, and then you can score it. And then you say, okay, if the score is above a certain threshold, this is good enough, I can move it on to my audience, or else I say, no, we need to do this again. So it's a feedback loop to provide the LLM, so to improve the fidelity of its findings. There are, again, some tools that are available that can do this. You can also create your own prompt to do this. But again, this requires a little bit of testing, figuring out how good are my responses, what is the threshold that I want to take, what is the threshold that I want to give to my customers or my developers. Okay, I think we're almost at the end of this, but talking towards the future, the models are improving every day by day. We have Opus 4.7 that was released, I think, a couple of weeks back, GPT 5.5 literally 2 days ago. Mythos is coming. That is the security-first LLM from Anthropic. The reasoning capacity has really, really increased, where we can do much more with these LLMs. We, as part of the defensive side of things, have to use these models and these abilities more effectively because our developers are developing and releasing things very fast. The other end, the hackers also have access to these models. They are also able to find issues very quickly. We need to increase the rate and the quality of the results that we get from our threat modeling and from our analysis so that we are able to have that sort of early shift left first check possible when we do these huge large-scale projects. And to conclude, security needs to move out of the long end-of-line PDF reports after weeks of reviews. That just doesn't work anymore. We need to be quick. We need to be as quick as the developers are, as the hackers are. We need to trust but verify. We are using AI. We need to understand what results we're getting. Like some of the results, if you see it, you're like, this is awesome. This is fantastic. This is perfect. But as you look through the results and as you put on your very critical security lens, you will find those issues there, where it's missing certain certain small things, where it's missing some things that you assume, as having worked with that system for a long time, that you assume that AI will understand. 0 minutes left. Okay, so And that's it. Like, as I think the previous person to me also, the previous speaker also mentioned, this is early days with how we are using and developing and utilizing AI. As things go forward, especially, very excited about, Mythos and all the stuff that will bring. We're going to see some very, very interesting times ahead. And that's it from me. Thank you, everybody. Thanks for listening.